Hi, everybody. Welcome, Azure Cosmos DB Live TV. I'm your host, Mark Brown. And this week, I've got a new guest with me, Chris Joakim. How are you, sir?
I'm well, Mark. Great to see you again.
Yeah, nice to see you. So viewers might remember that I had a teammate of mine on, Rodrigo Souza, and that was back in January, I think about a month ago now. And he talked about kind of, well, relatively new capability, new feature. And that is Synapse Link. And now Synapse Link, what's cool about that is that it provides kind of a no ETL way to do big data analytics on data out of Cosmos DB. And you can use both Spark, so you can create Spark jobs, run Spark compute underneath that, or using our SQL and SQL serverless. Now, what a lot of people may not realize is we also have, and that's why I invited you on this week, Chris, the capability to provide that same type of HTAP analytics for data in our Mongo API. And so I wanted you, if you could, spend some time and let's show users kind of all about what they can do if they've got data in Mongo. And the analytics, the kind of stuff they can do with that in Synapse Link.
Yeah, awesome. Yeah, let's do exactly that. I have a GitHub repo that I'm showing. Can you see it, Mark?
Yeah.
Okay, awesome. Yeah, so I come from this kind of crazy long app dev background, so I tend to do everything on GitHub. My role is a global black belt for Cosmos DB at Microsoft, and I absolutely love that. But I do get to touch code quite a bit as well. So this is kind of the outline of the presentation. So we're going to just talk about the architecture of HTAP again, following the last podcast with Rodrigo. So we're going to load some data into Cosmos, but let's create that data first. So I'm just going to show you how I create data for Cosmos, for sample purposes with Python and the Faker library. Then next, we're going to load that data into the Cosmos Mongo database with Java. We're going to see that data. We're going to use we're going to query it with Java, and we're also going to use the Studio3T Mongo client to view that data. We're going to configure Azure Synapse Link again this is the Cosmos Mongo API with Synapse Link. Next, we're going to do some aggregations. So again, we're going to kind of do some true HTAP processing. We're going to, work with Cosmos DB as a high performance, database, but we're going to do some aggregations, with that Synapse Link data, and we're going to populate an Azure Postgres database with that data. And yeah, so we're going to see that data in Azure Data Studio.
Cool. That sounds good.
Yeah, awesome. So let me show a picture of, let me talk about themes first. So, that one theme was going to be it is open source. The screenshots that you'll see below are from my Mac. Just in the last couple of days, I had some issues with that, and so I'm going to be presenting from Windows today. So you'll see the screens that I showed today are going to be a little bit different than the screenshots, but it's all essentially the same content. But yeah, we definitely want to show, the open source tooling and standard tooling that, you as a Mongo user are probably already familiar with. You're probably using Python, you're probably using Java, you're probably using the Studio3T tool. And then it's also, I mean, just for your reference, Cosmos DB, the Mongo API, you can use it with all the tools that you're probably using now, such as Mongo export, Mongo import, Mongo dump, Mongo restore. I actually had a customer in Europe in the last 2 weeks that they're using MATLAB, and they wanted to see if they could. They're using it with MongoDB, and they wanted to see if they could connect to Cosmos DB Mongo, and indeed they did. So yeah, a theme is you can just use all your existing tooling that you're currently using for Mongo. You can just use that with Cosmos DB as well. If you're not aware of some really great tooling we have Azure Data Studio. I'll show that. Azure Storage Explorer. I'll
Does
show
that still
that.
work?
Beg your pardon?
Does Azure Storage Explorer still work? I thought that got deprecated or something.
Yeah, it still works. It may have had Cosmos DB functionality in it at one point in time, but
Mhm.
you can use it for for viewing and uploading, downloading, and seeing blobs. So
Okay, right. Yeah,
that's what I'll be showing.
it was the Cosmos support that I think you can't get. You got to get a really old build of it or something like that, or even that maybe, I don't know.
Yes, yeah. All right, so the audience has probably heard, numerous times the term polyglot programming. That's essentially using multiple programming languages, using the appropriate one for the appropriate job. So I'll be doing a little bit of that, showing some Python, Java, Spark, Scala, PowerShell, Bash, etc. But maybe a term I just invented here is kind of polyglot architecture. So we're going to be working with Cosmos DB, doing some processing there. However, in true HTAP fashion, we're going to use the right tool for the job. So we're going to use Synapse Link and Spark to do some aggregation queries in Spark, and Cosmos for some high performance queries. And then just briefly not covered today because it was covered previously. So we're not going to cover the Cosmos SQL API. We're just going to cover the Cosmos Mongo API.
Yeah, if people want to go back, they can go and look at our episode 36. There it is. I'm looking at it in our show schedule there, and go find and watch Rodrigo walk through kind of the basics of Synapse Link.
Yeah. Yeah, I was just chatting with Rodrigo last night about something. Great teammate. All right, so just a summary here of HTAP again. I've kind of augmented the diagram that the viewers may have seen before. So essentially this box to the left in Cosmos DB, this represents your Cosmos Mongo container. So your documents are here. I'll show you how to easily set up the Synapse Link functionality that essentially in near real time, about 2 minutes, moves the data to the analytic data store. We call that the Synapse Link data store. And then we're going to, in this presentation, we're going to process that data with Spark. We're going to aggregate it. So what the data in question is actually some simulated sales documents. So we're going to aggregate sales by customer, and we're going to write those aggregates both to blob storage and to Azure Postgres database. So that's where we're going today. So again, kind of the big picture here is that Cosmos is great for the high performance queries, but for the kind of big data analytics and aggregations, it's kind of much better to do it here in the Spark and Big Engine. I'm sorry, big data engine here in Azure Synapse Analytics. So that's what I call the polyglot architecture, right?
It's fascinating just listening to you walk through this. I mean, you've got data in a Mongo format, stored in Cosmos DB, transition from a row store to a column store format. So we're writing it into Parquet format, and then you're going to create it with Spark, and then shoot it into blob store and into another operational database in Postgres. So just
yeah. Hopefully the audience will find this to be true by the end of the presentation here. It's so easy. It's so easy to do. Let me just kind of briefly call out one more thing. So here's the Databricks logo, sitting here by its lonesome up here. And it's really not needed anymore. So, some of our customers used to use Databricks, as kind of this ETL layer, right?
Yeah.
So they would use it and they would have a Databricks cluster, that costs money, and it would constantly be querying Cosmos to say, hey Cosmos, what are your latest documents? So that costs RUs, request units, and then they'd have to copy the data, query the data, get the data, so that's more RUs, and then copy it to somewhere like blob storage. So that's a very expensive kind of ETL solution. Whereas this is it's not free, but there's a low cost IO charge. The storage is quite inexpensive. But this is I call it like painless ETL. This isn't too bad, but this is utterly painless ETL to move the data from Cosmos to the analytic data store.
I mean, it's the real HTAP, right? It's a commercial offering out there where you can do both and not have one impact the other. So,
Yep.
Yep.
All right. So let me continue on. And Mark, just let me know if we get behind time. So
Yep.
the first thing I just want to talk about is data set generation with Python and Faker. So, I personally find it interesting when I do demos and when I create, POCs, proof of concepts for customers, it really helps to start with useful data, right? Data that kind of fits the scenario that the customer is trying to, implement. So, if one can kind of craft, appropriate data, for a demonstration or proof of concept, that's really helpful. So, the audience might be familiar with the concept of lorem ipsum, kind of like that Latin text that, you can just paste
Into your website or something.
yeah,
Yeah.
into a website to see the look and feel.
Yep.
So likewise, kind of creating this data with these libraries like Faker is one way to do that. So this concept is not unique to Python. There is a NuGet .NET implementation of Faker. Way back when I used to do Ruby on Rails development, and there's a interestingly named library called Factory Girl that was essentially the same thing. It would create simulated data
That's
flows.
a curious name for a gem, but okay. Uh,
Yeah, yeah, yeah.
there's
That
another library that I use quite frequently as well as Bogus, which I
Oh,
think
yeah,
I think that's actually maybe built on Faker if I'm not mistaken. But yeah,
nice.
same idea is you gotta. Hey, it's a database. It's useless without any data in there. Give me some way to generate a whole bunch of data real fast, and those things work great. So
Yeah.
yeah,
So let's let me just run the generator
yep.
first. So it's just going to be a Python program. Yeah. So by the way, I mean all this, everything I'm going to show, everything that runs, it's all going to be in the same repo, GitHub repo that I'm presenting from. I'm
I'll
sure
put that.
Mark will have that in
I will put
the
that back. I
notes.
had it up earlier, but I'll put that back up and leave it for folks. But yeah, everything you see is all on GitHub, so you can clone it and run it. And yeah,
Yeah. All right. So I'm just going to run the retail data generation script. And I'll run it and then I'll kind of explain what it did. And again, it's a Python program. Just about done. Okay, cool. It's done. So what just happened there is that it uses that Faker gem and it created a simulated product catalog, like with a product hierarchy, right? A product is in a catalog and it's in another master catalog, right? So a three-level hierarchy. So that was generated, with a simulated SKU or UPC code for each product. That was written to this file here, data retail product catalog JSON. We're gonna those documents in that file get loaded to Cosmos. I've already done that for product catalog and stores and customers. So yeah, so obviously stores got generated too, customers got generated, and I can show you brief examples of that. And lastly, we generate sales. So I generated sales from January 1st last year to today. So it's 413 days worth, 31,000 sales, 77,000 line items got generated. Furthermore, I split it into two different files, sales one, sales two. Sales two is today, is February 17th, and sales one is everything, all the other days. So we're going to load sales two. But yeah, let's take a brief look at Faker just because it's kind of fun.
yep.
So here's the Python code. So this is a retail data gen.py in the repo. In the requirements file, I'm including Faker in the script here, line 30. We're just importing it. Cool, pretty easy. And yeah, I mean this isn't rocket science, but it's kind of a useful tool. So here
You
in
just
the
define your properties and then just start generating data, right? And just say how many rows you want on it, and
yep,
then start generating it, and then and then outputting that to wherever you're going to output it. And I think in your case, you said you shoved it into a file, so there you
yeah,
go.
yeah. So just going through a for loop, we're creating an instance of Faker
Yeah.
called fake, and then doing this for loop, for X number of stores. I forget what the number is, but so fake.city, fake.street address, fake.state abbreviation. There are hundreds of methods available in different domains. Retail SKUs and manufacturing and telephone numbers, and it's pretty useful. Credit
Yep.
card numbers. So yeah, that's kind of my go-to library for creating data. And lastly, it just got written out. So that's the data. So that's kind of cool. So let me show you the next thing. So I want to show the actual sales documents, and then I want to talk about design because that's kind of important. So I'm just going to run the display sales script. All right, and what it's doing is that, so remember there are thousands of sales generated. So this is just the first sale. And so Cosmos DB is schemaless, right? There is no schema, other than choosing a partition key for each container/collection. It's schemaless, so each document can look different. And in fact, it's often a great idea to do exactly that, to store dissimilar documents in the same container. So Cosmos DB is not, like a relational database. So you don't have to create a separate container for your orders and one separate container for your line items and a separate container for your deliveries, et cetera, et cetera. They can all go in the same container if that's appropriate. And in the case of this application, the sales and the line items, it makes total sense to put them both in the same container. So
Yeah. You even shove customers in there too.
yeah, we could. We absolutely could.
Yep.
But back to the concept of the partition key. So there's 4 documents for sale ID 1. So now you can kind of leverage a couple concepts. So one, every Cosmos DB container requires a partition key attribute to be defined. I typically use just PK because that kind of gives me the flexibility over time to populate that attribute with an appropriate value. Right now, I'm just using the sale ID as the partition key, right? Sale ID 1, partition key 1. But what's interesting is that just so I can tell apart what the different document types are, I use a doc type attribute. So doc type is sale, right? And it has information about the sale, like the customer ID. But in the same partition key, so there are line items. So in the same sale, notice how it's in the same partition key, right? Line item 1, for a certain SKU, certain quantity, etc. Line item 2, line item 3, etc. So what's really great about that is that you can efficiently query either the sale or the line items or both, efficiently because it's in the same partition key, right? You don't need to do a cross partition query. So that's kind of a good design practice.
Yep. I like
now,
I like your using of just the generic PK as the partition key in there. That actually, at least early on in design, can give you some flexibility. If you decide you want to use a different partition key, you can then essentially just annotate that differently in your classes and have that map to whatever that is. I mean, it would allow you some flexibility to you couldn't change the value, but you could copy it back into the container with a different key with a value.
yes, yeah,
Right.
yeah. So
So
you can
that
kind of
could give
like
you kind of some, like if you screw up today, like say you made it sales ID or store ID, and then you decided, you know what, I want customer ID or I want something else, you would have to migrate the data wholesale into a new container. Versus if you use PK, you could actually copy it back into itself with a different value. Right.
Yeah, exactly. Yeah. So yeah, it offers schema flexibility.
Yeah.
Yeah, just a subtle difference between how one often does things with MongoDB versus Cosmos Mongo API is that notice I split these out into separate documents. Folks using Mongo itself might actually choose to put this all into one document with an embedded array of line items. And the reason why we generally don't do that with Cosmos is that, let's say we have to update this line item. We had to, maybe there's I didn't build it in there, but maybe there's some status attribute and the line item goes from, pending to shipped, right? So, this way we can just read and update a very small document as opposed to reading the whole order or sale document, and updating everything, right? So this is actually going to cost quite a bit less than updating what I call a jumbo document
I've seen. I mean, and I've given a guidance on going either way with that. What I do say is, as with anything, you just need to measure. Like if it was like say a shopping cart where you're adding and removing items quite frequently before you push the sale, making them separate documents may make a whole lot of sense, where you're making lots of changes to what's in the shopping cart. But once you make the order, maybe not so frequently at that point. And so if you wanted to embed it into a document, you could once the order's been submitted, because it's less likely to change at that point.
Yeah. I agree with the measure sentiment. All right, so that was the dataset generation. So we talked about the document design, partition keys. Here's some screenshots from the Mac. It looks similar enough on Windows. So next is let's load that data. All right, so let's use Java now. Let's be true polyglots, and we played around with Python. No, let's move on to Java. So let's move on to the next tab. Yeah, Gradle. Just to evangelize slightly about Gradle. So this is kind of funny. I did Java development like forever, literally decades, and I just kind of discovered Gradle as a much simpler build tool. Gradle. Beg your pardon. There we go. Build Gradle. So when I started a Java project in the Maven world with XML, I spent like the first 6 hours of the project, figuring out what XML to use for my Maven. Whereas with Gradle, it's so simple, and it's very much like a .NET CS project file. I mean, so this is all I need to do to specify, okay, those are my dependencies, with the Maven coordinates, right? So we're just going to use the Mongo driver, the standard MongoDB Java driver that customers are probably already using. We're specifying Maven Central as where these artifacts are, and we're good to go. And Mark, it sounds like you're familiar with Ruby and Ruby on Rails. So one thing I like about the Gradle file is that it gives you. Did I just cause you to laugh, or is that a cough?
Yeah, I'm just shaking my head no. I'm going to deny any knowledge.
So it kind of gives you the ability to define tasks. So from a command line, you can just do Gradle load customers, and it runs this code. Really, really easy to use. So where was I going with this? So let's load that data. So Gradle. So again, I'm just going to load the February 17th data. So I'm going to hit enter. I'll show the Java code in a second. So it's just reading one of those JSON files. There we go. It's loading all those documents as they fly by right now. I think it's 350-ish. All right, cool. So that took about 14 seconds. Let's just take a look at that Java code. And kind of the intent here is to say, this is just the same old Java and SDK that you're probably already currently using anyway, right? It's Cosmos DB, but you can kind of bring the tools that you're familiar with already. So it's just that Mongo driver that I showed here in the build file. Here it is, org MongoDB driver. So that's the library that's being used, and the application code is utterly unspectacular. You're just using the typical import statements for those the objects.
Hey Chris, your audio is breaking up a little bit. I don't know if it's on your end or my end.
Okay. How is it now?
Not any better.
Okay. Let me keep going. Let me increase it. How is it now, Mark?
No difference.
Okay. Let me unplug my Java device and see if my laptop doesn't.
Okay. Yep. Sorry, folks. Technical difficulties. It's a live stream, so this is what can happen. I can't hear you at all. Oh, you're on mute. Here we go. You're still on mute. You're on mute. Hold on. Can't hear you. Hey, Chris. I can't hear you. Reboot, huh? Okay. Sure. Okay. Sure. Okay, folks. So our guest is going to reboot his machine. That was unfortunate. Oh, hold on. Let's see. We may have him back here.
Am I back?
You are back.
Okay. So I disconnected the Jabra and I just simply reloaded the page. So yeah. All right. So that's live demos are always challenging. I was expecting something else to fail in the demo rather than the
audio. Yeah.
Here we go. All right. So anyway, just continuing on. I think I just loaded the database.
I need you to share your screen again, if you could.
Okay.
There we go. It happens with me too. So we've got anyone that's ever done a live stream or anything live at all, actually. Can't tell you how many times I've been live on stage and had all sorts of tragic things happen to me. So, okay, I think we're back.
All right.
Thanks everyone for sticking with us.
Yeah.
Yeah.
We don't give up easily, so we're gonna forge on here.
There we go.
All right. So the Java code is utterly unspectacular. It's using the same library that you're probably already using anyway if you're using Java. So we're creating a Mongo clients with the Mongo clients create, and this is simply the connection string. Sorry about that. That's the connection string that you would get from Azure Portal. You can literally use that value verbatim. And then once you have Mongo client, you can do things like insert doc with it. So again, it's utterly unspectacular code. It should be all very familiar with you if you're currently using Mongo, MongoDB itself, as opposed to Mongo in Cosmos. All right. So let me accelerate a little bit. So we just loaded some containers. So let's do some queries now.
Yep.
So let's use our handy dandy Gradle.
So this thing, I missed your app or maybe some of it. So you have what, like public functions, public methods within there, and this thing just calls right into them directly without going through main.
Well, no, that Let me pop that code up again real quick.
Sure.
So yeah, I have a DA, what I call a DAO, data access object. I simply call it Mongo, and so the main entry point is called app. Much like in .NET, it's program CS. So with Gradle apps, it's called app.
Right.
And then the app, the main program calls this Mongo DAO, to execute Mongo operations.
Okay. So, I don't have to annotate anything. It just
so you might notice like the insert doc, so I just ran the inserts. So I have an overloaded method here where you can provide like an actual BSON document from the Mongo SDK.
Sure.
Or just I'll play an old Java hash map, key value pairs, and it'll create a BSON document out of that, and then invoke this method. So it's this should all be code that's familiar to folks that are using Java and MongoDB right now.
I think I like this better than what I do in .NET or C#, which is I got a bunch of like public methods, and then I have to create like a menu type of thing, and I put it on a while loop, and then it just prints out the menu, and then I do a key capture or a read key on whatever I push, and then it executes the function.
Yeah. Okay. Interesting. Yeah. With the .NET, I love .NET, but the program CS and just having a single entry point, that kind of forces you to have like a switch statement in that.
Yeah. Exactly.
but the thing I like about the Gradle is that it allows you to create these different tasks to do different things.
Yeah.
Load customers, load products, etc. And it's all going to invoke the same main program, but with different functions, right?
Wow. All right. This is cool. There's got to be something like this for .NET. I don't know.
Yeah.
Viewers, if there's something like this for .NET, would you please put it in the comments? Because I could use an easier way to design. Like I build demos all the time, and I have to do them with this stupid little menu thing, and it sits in a while loop, and then it just basically keeps going through. And if I hit a read key, it then executes the function.
Yeah.
So, but this is simpler. It's all command. It's all running in the shell anyway, and so this would be even easier. So, okay, I'm sorry. I go on tangents sometimes.
That's all good.
You show me shiny things, I'm gonna chase them.
Yeah, and I'm happy to talk about code. So let's find that sale. Let's find a sale by partition key. There it is. And so as we saw, I made an errant coding.
Did I make you type stuff into your app there?
Yeah.
Sorry.
No, that was my fault. Let's see if I can get this one out of the ditch again. So app config. Here we go. That's the thing I love about IDEs. They give you that context assist. Build. Yeah, Mark, I did not anticipate doing this during the demo, but there we go.
Hey, like I said, it's a live show, man. And if you're doing live coding or live debugging, that's fine. That's why we're here.
All right, so I think I fixed the program error that I introduced. All right, so we're gonna find that sale by partition key. So I think the parameter I gave was partition key or sale ID 30,065. So indeed we have the sale document and the line items. So there's a line item, same partition key, and another line item. So indeed that Mongo code, that Mongo Java code, it just it just works unless you make silly typos like I just did. All right, so let me move on. I'm going to accelerate. Yeah, so just to again underscore the fact that I'm going to copy these. That Cosmos DB, the Mongo API, it just works with the tooling that you're probably already familiar with. So here's the Studio3T, Mongo client. It's pointing to my Cosmos DB account. I'm going to do a query on sales container. I'm going to paste in my own queries. All right. So first, let's count how many documents are there. And 100. I know the font's really small. 110,000 documents. That's cool.
Yep.
And that query that we just did in Java, let's do essentially the same query here, and there they are. I mean, the output isn't pretty printed like I did in Java, but that's essentially the same thing. A sale and two line items. So again, the whole point of showing this is just again to say that Cosmos DB or the Mongo API, it quote unquote just works with the tooling that you're already using. And again, Mongo import, Mongo export, tools like that as well.
Yep.
All right. What is next? All right, screenshots on that. All right, so let's head back into the world of HTAP and Synapse. So I think I'm done with the desktop and Python and Java. Let's go to Synapse. So back to the big picture again. We've done everything here, all the clients. So let's configure. Let's briefly configure what we need to do in Azure with your Cosmos account. So here is my Cosmos Mongo account in Azure Portal. And it's really quite simple. All you really need to do in the Features tab here, there's this feature, the Azure Synapse Link. You just need to click it to toggle it on, click Save, and that's half of the job. The other half is on the individual container. So let's go into Sales. In the settings. So I have the analytical store, meaning Synapse Link, turned on. I have it set to a time to live. I forget what that value is. So basically you set that value in seconds. That might be like 30 days or less. Might be several days. But the point is the time to live on the Synapse Link side is optional. But if you do use it, you can specify a very granular expiration in terms of exact number of seconds. All right. So wow, that was pretty much all we needed to do to enable Synapse Link, with the Cosmos Mongo account.
So you can just go and turn that on, even if you've already got your container already created. So I think we've made that a new capability, if not mistaken, right? So
yes. Yeah, so you can, before you used to have to enable that at the time of container creation, right,
Yeah.
Mark? But now you can do it after the fact.
That's great. So you don't have to, if you've got an existing workload and you're like, hey, this Synapse is pretty awesome for doing analytics, so I'm going to check it out. You can. I think you can turn it off now too.
Yeah, I was going to say that. So I just mentioned I had a chat with Rodrigo yesterday or this morning, and it was about that very topic. So, some customers are asking for, hey, can we, disable it, at some point in time, and that functionality is coming like in the next month or two.
Is it? Yeah. Okay. If it's not out, it's coming soon.
Yep.
Yeah. So that's good. You can kick the tires on that, turn it on, create or provision some Spark compute or some SQL serverless compute, create a new workspace, some notebooks, write some queries. So, okay. What's next? So you got it configured here. We set, you could set an ETL if you wanted to on the analytical side, but you don't have to.
Yeah. So the next thing is let's go into the world of Spark, and let's, back to the big picture here is that, we use the Java client to send data into Cosmos, the Mongo API. That data by now is surely here in the analytics store because it's been more than 2 minutes. And so we're going to run a Spark job, Spark Notebook. So, Azure Cosmos DB, this is kind of Microsoft's flagship NoSQL database. And likewise, Azure Synapse Analytics, that's our kind of flagship, big data processing PaaS service. It contains several things. There's at least two compute engines now. One is SQL, otherwise formerly known as Azure SQL Data Warehouse. The other is Apache Spark. So that's what I'll be showing today. What I love about Spark is that, yes, you can read this analytic store data with Spark, but you're not limited to that. You can read Blob, you can read Data Lake, you can read or write to actually any of these Postgres. A very, very large list of other things you can do. There is like Azure Data Factory functionality is in Synapse Analytics. You can integrate with Power BI, et cetera, et cetera. So this is a very comprehensive product, Azure Synapse Analytics, but we're just going to play with Spark right now.
That's a good point, is you could bring together multiple operational data stores in a single place by just creating a linked server connection to them via Spark, and then start writing queries against those different, just open row sets against those things, and then just start writing queries against them, right?
Yes. Yeah. I mean, the beautiful abstraction is in Spark is the quote unquote data frame. All the data essentially can be read into a data frame, much like a pandas, a Python pandas data frame. All these dissimilar data sets, sources can be read into a data frame, and then you can process them. And some of that processing includes joins. Yeah, so this is worth digressing, Mark. So, back to joins in Cosmos DB, sharp viewers with a sharp eye might have noticed that there was a customers container and there's a sales container, and that kind of leads to the question, well, gosh, can you join them? And, you can kind of join it in the application code, right? And if you're reading the Cosmos Mongo, you can read the container, the customers container, read the sales container, and then your application code, you can kind of, join them, but that's not a true database join. What's beautiful about Spark is that you can join multiple data sources, if they have like a common key, such as customer ID. So, a great example here is that, the customers table or collection that's in the analytics store and the sales container that's in the analytics store, those can be read into two different data frames in Spark and joined on the customer ID, right? Furthermore, right, if you have that customer ID in a data lake or blob or somewhere else, you can join on that as well. So it's a great processing engine. Yeah, so I'll talk about that a little bit further when we actually run.
Very big Uber point. I wish I could put like some kind of key graphic, like the more you know, kind of flying across the screen there, because that is a huge meta point about what you get when you put your data into Synapse Link.
Yeah, exactly. Yeah. So again, just to underscore that, I mean, the purpose of HTAP is to do the processing, with the right engine at the right time. So Cosmos is great, for the ingesting data at high speed, for doing partition key queries, or even non-partition key queries, for a limited data set, but I wouldn't aggregate all my sales for the year. I wouldn't read all those documents and try to aggregate them in Cosmos. A much better solution is to aggregate them here. So that's what I'm about to show.
Yep. Okay.
Cool. So yeah, back a little bit more configuration. So so what I'm showing now is the Azure Synapse the Azure Synapse authoring experience. And sorry for that. Yeah, workspace. Sorry for that hesitation. I was just doing a time check, and I think we're on track.
Oh, you're fine.
Yep. Yeah. So in the workspace in Synapse, you create a quote unquote linked service. So this is kind of one of another Azure service that I'm going to be using in my Synapse workspace. So I have it pointed to my personal blob storage account. And notice I have it pointed to two different Cosmos accounts. One is SQL and one is Mongo. And I'm going to click into each. And it's basically I do the same demo to, I'm not sure why it's not scrolling. But yeah, essentially both Cosmos Mongo and Cosmos SQL, here we go, have the same structure. I have the same containers. But today I'm going to focus on the Mongo. So these are the underlying containers in my Mongo Cosmos Mongo database. And this little subtle icon, the vertical line that indicates that it's the column or data store. So back to this picture here. See how it's horizontal here, the lines, and this is vertical for the analytic data store. Yep. So likewise in the portal, we have that same UI experience where it shows it as vertical. All right, so now that I've defined the link services, let's actually use them in a Spark notebook. So I have already created that notebook, and let me go into full screen and let me just kind of talk through the logic of this first. So the cool thing about notebooks is that you can kind of have, comments or markdown cells and code cells, and the code can be Spark or Scala. PySpark or Scala or SQL or other engines. All right, so the purpose of this notebook is basically we're going to read that Synapse Link sales data, and we're going to aggregate it by customer, total sales by customer, and we're going to write those aggregated results to Azure Storage and to Azure Postgres database. Okay. And basically, so there's going to be a number of cells down below, and each cell kind of does these things in turn. So I'm going to have one cell that defines some common functions, much like you would in Python or Java or any other language. We're going to load that Synapse Link data for the sales into a Spark data frame. We're going to sort it and display it just so we can verify that indeed we got the February 17th data, which is the last set of data that I loaded. Then we're just going to weed down that larger data frame with 20 columns into something smaller for the aggregations. Then we're going to do the actual aggregations by customer. And we're going to do a handoff from Python to Spark to Scala via a temporary view. That's kind of that was kind of I just wanted to introduce that concept of a temp table in this demo. We're going to write that aggregated result to Azure Storage, and we're going to also write that same result to Postgres.
That's a whole lot of stuff.
That's a whole lot of stuff, but it's not very many lines of code, which is the beautiful thing.
I got a question. Do you run into, because you talk to customers all the time and developers as they're working on building solutions and stuff. What do you find? How do like kind of your regular kind of like .NET or C# developers react when you show them notebooks? Do they, particularly like Python, do they get kind of spooked by these things or confused, or are they like, wow, that's pretty cool? Or maybe it's a mixture of both. I'm just kind of curious because I like these things. Like for me, I had never really experienced or played with these things until I got into kind of this, until we started doing more of this work with the Synapse Link and stuff.
Yeah.
And I know these things are where folks like data scientists and data engineers and others kind of live all day in these things. And I can see why, but I'm just curious because it seems like there's almost a convergence where this is certainly much more accessible now than it used to be. But how do they react to these things, I guess? Yeah,
generally positive. Generally positive. And Python is kind of taken over the software development world. What's that organization that ranks the programming languages by popularity? And in the last few months, Python became the #1 most popular language. I think .NET is there, Java is there. Those are the top 3, but Python emerged, and because it's so darn practical and it's usable here in big data. So yeah, certainly data scientists are happy with Python. But you can also run Scala, which is essentially Java, in a notebook as well. So it caters to that audience too.
I know the DevDiv folks introduced C# or .NET type support for notebook. Is that supported in Synapse as well?
I believe it is, Mark. I haven't dabbled in that myself.
Yeah. All right.
Yeah, I have a bit more of a Python background.
Yep.
So
yep. That's no. Yeah. I'm not asking you like. I'm just curious if you'd seen it C# running in a notebook in Synapse. But I'll have to try that myself. Okay.
All right. So I just scrolled down and I saw that the job didn't quite run, so I'm rerunning it. I think we're challenged by the demo gods here, but bear with me. All right. So. So this to remind the audience, this is kind of what the input documents look like, in Cosmos. And so this is kind of the crazy cool part, Mark, where you can essentially read that Cosmos data in very, very few lines of code. So I'm talking about these right here. So let me just kind of step through that. So we're just saying Spark read. And we're reading the Synapse Link data, and that's the OLAP, and we're connecting to the link service, that's my Cosmos Mongo database, and furthermore we're specifying the sales container, and we're loading that, and furthermore we're going to filter based on some timestamps, greater than or less than a certain timestamp. So that's all the code that's needed in Spark to actually read a data frame, read the Synapse Link data into a notebook.
That's pretty cool and very concise too. That's great.
Yeah, and because I come from a Java background, of course I have to have logging. So I have a bunch of display statements, and I'm printing the shape of the data frame, meaning the number of rows and columns. So, it's 110,000 rows, 20 columns in the data frame. Now, let me talk about something here. So there's a method called print schema in a data frame. And so Cosmos DB is schemaless, right? But yet we're printing the schema. So let's talk about that. So indeed, there is no schema in Cosmos Mongo. However, Spark is kind of inferring the schema based on the observed data. And this is kind of like what the schema is. So basically, like the ID is a struct of an object ID. The partition key is a struct that contains a string, et cetera, et cetera. So there is some implicit, schema on read that's happening here. All right, just displaying a few like the top few documents. Okay, that's cool. The next cell, let's see, what are we doing? We're just going to display the newest documents. So basically, we're going to take that original data frame that we just created up above, and we're sorting it by the timestamp attribute, order by the column timestamp, and we're going to display that shape, and then we're going to display the first 30 documents. And I'm thrilled in that I'm seeing indeed the February 17th documents are which is the ones we just loaded with Java a few minutes ago. Those indeed are at the top of the list. So back to this picture, we populated the container with Java. That data is now here, and we just queried it and proved it, and that these documents are the ones that are.
Yay, it's working.
Up. Yay. Yeah. So our microphone isn't working so good in this demo, but it looks like.
But the synapses, that's good.
Yeah. All right. So continuing on. Yeah. So we're just going to whittle that raw data frame down to a fewer, and we're just going to select a few attributes from it, such as doc type, date, customer, item count, total cost. I'm going to kind of zoom through this in the interest of time. Again, printing out its shape. It's down to 5 columns now. Here's a few of the rows. Let's do something more interesting. All right. So this is what we came here for today, is the aggregation. So what we're about to do again is we're going to aggregate all those sales by customer. And before we do that with the Spark code, let's just talk about, like, alternatively, what would we have to do, right, if we just read the data straight out of Cosmos, right? So first, we'd have to get a list of all the customer IDs, and that would be a cross-partition query, So that would cost a few RUs, right, to get the, in this case, I have 10,000 customers, and then once we have that list of customers, we'd have to iterate through it. For each customer, read all of their sales documents, within the time frame. And again, that would be a cross-partition query. It could get a little bit expensive. And then in code, we'd have to sum all those things up. So, I think that would be, fair to say a few hundred lines of code, maybe a couple hundred, certainly. But furthermore, it'd be expensive. It would consume quite a few Cosmos RUs.
You mean as a ag pipeline query? This would be a few hundred lines of code, or?
Well, yeah, good point, Mark. So I'm wearing my my Cosmos SQL hat in my thinking, but not my Mongo pipeline. So good point. I didn't think about that alternative, but still, it would involve kind of like some cross-partition queries, and chances are it wouldn't be the most cost-effective query.
My thinking is, and depending on how much data you had there, you have a couple things working against you. You have bounded execution, right? So we'll only let things execute for a certain period of time, and then we'll cut it off and return back whatever you got. And then there's also the 40 meg limit as well that we've got in the gateway for payload on what we'll send back to you as well. So there's kind of two things that Cosmos is, like as you said earlier, is awesome for high-speed operational database. It is not intended really for doing heavy analytics, right? It's not architected that way. that's what makes something like this so fantastic. You can do that as well as join it to all these other different types of data, operational data you've got to really build robust analytics. So.
Yeah, exactly. So, again, back to polyglot programming and architecture, using the right tool for the job. So yeah, so this is all the code necessary for the aggregation. So I'll just talk through it real quick. So in taking the original sales data frame, we're going to group it on customer ID. That's super readable. And then we're going to aggregate it and into several columns. So we're going to take the first ID, so we can basically have the customer ID, so we can write this to Postgres and correlate the ID in Cosmos versus the ID in Postgres. Likewise, we're going to get the partition key. We're going to get a count of the orders for the customer. We're going to get a sum of the total cost of the customer's orders. And we're going to call, the alias is going to be the column name in the output data frame, which is this. And likewise, we're going to get the item count, which is a sum. We're going to, assign it that name in the output data frame. We're going to display the count. And so indeed, it boiled down to like 9,590 rows, 6 columns. Those are the 6 columns, order count, etc. There's a sample data set there, so customer ID 1 has 3 orders and $12,000 and 7 items. All right.
Man, what are these guys buying?
They're buying fake products, Mark.
I was gonna say, what kind of, man? It's a faker at like a Gucci or a Hermes store.
Yeah. It was faker with the Gucci flag turned to true, I think.
Wow.
Yeah.
That's some high quality faking.
Yeah.
High quality products. I like it.
All right. So that aggregated data set, data frame, or this is some verbose code to write that to a blob account. Blob storage CSV file. Let me open up Storage Explorer real quick. So here it is. And notice how it's like one CSV file. And I like that. And how that was done, you can use the coalesce function of your data frame. So coalesce it into one file. Kind of big data processing, it works in parallel typically. So alternatively, if without the coalesce, that CSV file, it might have been several parts. There could have been several parts to this file, but because of the coalesce, I turned it into one file before writing it to blob storage. Yeah, this is kind of cool. You can toggle back and forth between Python, or what are called PySpark, or Spark. These are called the magic commands. So this is going to use Scala now, and we're going to write to Postgres, that same aggregated data frame. We're going to write it to Postgres using JDBC, and we're simply going to write it. Format JDBC. With the URL, the driver, the table, the user, password, etc. All of these parameters we got from Spark configuration that can all be set in Azure Synapse. In the interest of time, I'm not going to show that, but it's in the repo. It's very, very straightforward. All right, so that was indeed done. So Mark, I'm about to head over to Azure Data Studio. Any questions about the notebook?
No, this is super awesome. And by the way, folks, next week I've got Chris's teammate on, Sergey. He's going to talk about Spark streaming, and I know he's going to go into kind of Spark config. So no, don't worry about any of that stuff. So
okay, awesome.
This is more areas that it's great having you guys on to talk about this stuff. But no, this is just fascinating. When I first saw notebooks, I'm like, I scratched my head on them. I'm like, I don't understand these things. It doesn't feel like what I'm used to, which is living in an editor, like in some kind of text editor or whatever. But I immediately started loving them because it was so easy to access data and visualize it. Like there are tons of awesome visualization capabilities you can get in notebooks through kind of Python. And these things like MATLAB that you were talking about earlier. Yeah. And there's all these other great ways to not just access data, but manipulate it, load it. You can do anything CRUD wise on the data, but just there was, I thought it was a really easy way to visualize it. And also they're portable. I mean, you can share them as well, which is also kind of cool. So you could check it into source code and share it with your team or whatever. Anyway.
Yeah, exactly. So Synapse can be integrated with Git, right? You can do that. So like Azure DevOps has Git, you can point to GitHub, etc. You can export these. You can export as a IPython notebook file and store it in source control that way. Mark, you might like this. I mean, I know you're a user of Visual Studio and other IDEs. So even in the browser, you get this editing experience. So see how we get this pop-up, context sensitive help here, Spark. So I'm going to do Spark read, etc. I don't know if you can see the.
Very cool.
Yeah. So it's not just a primitive coding experience. It's quite a bit more advanced than that.
Got the auto completion going on there, and
yeah.
Yeah.
All right. So I think we're done there. So let's go on. The last topic is Postgres, right? So this data frame did indeed write out when it says done here. So this line, it got to this line. So it did write the 90 rows to Postgres. So let's just go to Postgres and verify that. So that is the wrong tool. So this is Azure Data Explorer. So let me digress a little bit. So the Azure Blob Explorer that I just showed, that's a free Microsoft tool. It's free. You download it. It runs on Windows, Linux, Mac. Same with this Azure Data Explorer. Free tool. Runs across multiple operating systems. It's a great tool. So yeah, this is kind of my go-to tool. I mean, so this works with Azure SQL. And also with Azure Postgres. So let's just count the number of rows in that Postgres table that was just populated. So indeed, we're getting the exact same number, which is great, Mark. 9,590 rows. So let's see what they look like. And that all looks about right. So customer one has 3 orders, back to that $12,000 of Gucci things, Mark.
Yeah, right.
So this shows I tried to show Microsoft tooling that's free, standard tooling that customers might be using like Studio3T, their favorite Java IDE, so I'm using IntelliJ, but you can use whatever you want.
Yep.
Bring your own tool and use Azure and use Cosmos, and it's all good.
And that's awesome. Really cool, showing really just kind of running water through the pipes here in the data, where you just loaded that out of Faker into our Mongo API for Cosmos DB, and then very easy with configuring Synapse Link. Give it a couple minutes to flow into the column store, and then look, you've got this great experience with the notebooks and being able to connect to and query all of this disparate data. I mean, it's really fascinating, and we'll see more next week as I'm thinking about this. Like Spark really kind of can provide kind of glue to bring data together, but it's not just the analytics. There's also the streaming aspect of it as well, that you can go and really integrate disparate data into these systems. So you can do both those things. And, next week we'll see some more of that. But this is, fascinating. You can take and process this data from all these different data sources and then go and use, say, Postgres as a serving layer for this, or you could write it back into Cosmos and use that as a serving layer, and then build dashboards on this stuff. And you can do machine learning. I mean, I'm looking at your graphic there, but you can go and train and run ML models on your data, and then write those results back into some kind of serving layer as well. So it's just the space has evolved so much and gotten so much better integrated and tighter than, I mean, I did ETL type stuff way back in the 90s and early 2000s. And
yeah,
man, that was a lot of just the writing the jobs themselves was so just fraught with, I mean, it was difficult, right? Testing them, keeping them up to date. I mean, things change and everything breaks, and they were fragile as well. And now things are just in a much better, easier state. And this is just it's more accessible, I guess is really what I'm trying to say.
Yeah. And just a couple things just to add some additional content here. So, I showed a notebook, right? And so, how do you actually run that in production, right? So, Spark, Azure Synapse has this functionality called Azure Data Factory, where you can, so Azure Data Factory is essentially like a big data orchestration engine that can do various things. It can read data, write data. It can invoke notebooks, right? So you can have a pipeline in Azure Data Factory that executes, steps in parallel and sequence. It's up to you. But one of those things that it executes can be a notebook. Much as like I just demonstrated today. So back to the ETL that you were just talking about, Mark. You can do that. Certainly in Azure Synapse with Azure Data Factory.
Well, that's interesting. I didn't know you could create steps or jobs in Data Factory to execute notebooks. That's kind of cool.
Yeah, it is. And one other thing just to leave the viewers with. So, please, if you wish, go ahead and clone that repo, play with it, kick the tires. There's coding samples in various languages. Here's kind of a map of the repo. There's .NET code, there's Java, there's Python, the Synapse things.
There's something for everyone.
There's something for everyone there. Yeah, absolutely.
Well, this is great. Chris, thank you so much for joining us. I'd love to get you back on the show sometime.
Awesome.
We'll talk offline. I know there was, I think, one other topic you were interested in coming and talking to our viewers about. And so, we should plan on that. I hope you enjoyed your time with us this week, and I hope you folks enjoyed it as well.
Yep.
Just a few quick announcements. We've got our Cosmos DB user group that we started, and our next meetup is going to be next Monday. Lenny Lobel is going to come on and talk about how to write queries in our SQL API. So come and join us there. That's have the URL there below, and you can come and join us on Meetup and watch us live on YouTube. This is episode 40, by the way, so we've got 39 others that we've recorded. So definitely come and check us out for all of our other shows on demand. So AKA MS, Cosmos DB Live TV. And then lastly, we've got Azure Cosmos Conf coming April 19th and 20th. And we have a CFP open now till March 10th. So if you've built and run applications on Cosmos DB, you should submit and share your knowledge, share the journey, excuse me, of building and running your apps on Cosmos DB. So come and join us for that as well. I see a comment in here. Nope, just a thank you for our show today. So next week, I kind of alluded to this earlier. We have another special guest, teammate of Chris's here, Sergey. And he's going to come on and talk about our, well, I don't know if it's new, but it's relatively new, our new Spark v3 connector, and how you can use that to do either bulk loading of data into Cosmos or migrations, or I think we should talk about streaming as well. That's kind of another kind of a key thing you can do with that. And so that'll be next week for us. So that's it for this week's show. Chris, thank you so much for joining us. It was really great having you on, and very cool what we've done with, able to do these types of HTAP analytics on MongoDB data and pull all kinds of different stuff together. Just very, very cool. Yeah. And so thanks for coming on and showing us.
All right. Thank you. Thank you, everybody.
All right. Thanks, everyone. We'll see you next week. Bye-bye.
All right. See ya.